Hello everyone, hope all of you guys are doing well, and this is your pre-lab assignment help for experiment 11, which is coordination compounds. Okay, question number 1. So question number 1 is basically asking you to name a coordination compound. Okay, what is this coordination compound? You have copper sulfate and 5 water molecules. So copper is a transition element. You guys know that when you are naming a transition element, you want to make sure that you write down what is its oxidation number or the charge. Okay, so the coordination compound, here we have copper. So copper, is it a main group element or a transition element? So transition elements you find in the D block, right? So copper is in the D block, which you guys have learned in Chem 1. And then how do you know whether it is copper 1 sulfate or a copper 2 sulfate, copper 1 or 2? One way you can find out is this is copper sulfate, right? Copper sulfate. Just to remind you how you need to find out your charges. What we know is normally sulfate is a polyatomic ion, negative ion. You can refer to the polyatomic ion chart, and then we know sulfate is -2 charge of sulfate. And copper, so here this is a polyatomic ion, copper, and this is a 1-to-1 ratio, meaning the charge of the copper and the sulfate needs to be the same, right? And we know sulfate is -2, so then the copper has to be +2, right? Also you can do it in the crisscross way, the reverse crisscross that we had learned. So 2 goes here. So since the ratio is 1-to-1, so this also need to be 2, 2, 2. And since this is an ionic compound, let's say you write copper is 2 and sulfate is 2, right? Because the copper charge is 2, sulfate is charge +2. So you crisscross the charges, the numerical value of the charges, so that you can get the subscripts. Since it's ionic compound, we normally try to get the smallest ratio. That will make it copper sulfate, like this. And by doing this process, by looking at the charges, we were able to find out that the copper is going to be +2. So then this is not the correct answer. This is also not the correct answer. So it has to be copper 2 sulfate. Okay, so we figured out the name of this part. And then when you have 5 water molecules, how would you name it? It is, if you have just one, that would be monohydrate, dihydrate, trihydrate, tetrahydrate, 5 for pentahydrate. So copper 2 sulfate pentahydrate. So this is copper 2 sulfite. Sulfite is SO3. So that's not the correct one. Sulfate. So it should be copper 2 sulfate pentahydrate is the answer. Okay. The next one. Calculate the molar mass of copper sulfate pentahydrate. Express your answer to 2 decimal places. Well, you guys know how to calculate the molar mass. You find the copper molar mass from your periodic table. I believe it's 63 something. Yes, 63.546. Excuse me. And sulfur is 32.065, and then oxygen 16, and then you also need to calculate 5 water molecules. So don't forget your 5 water molecules. So each water molecule, 16 plus 2 is 18. So 18 times 5 is going to be your 5 water molecules. Calculate the molar mass, and then you can write it down, which you know how to do it. I'm not going to tell you the number. Okay. Question 3. When you dissolve copper sulfate pentahydrate starting material in hot water, the copper ions will be surrounded by water molecules to form. Okay, so this is what you're going to be doing in your experiments. You will read the procedure. You take copper sulfate pentahydrate, I believe about 7 grams, and you dissolve in water. Yes, so you take 7 grams and you put it into water. Now this is a solid, copper sulfate pentahydrate. It's a blue solid, beautiful blue color. And then the water molecules come and surround copper sulfate. We know copper sulfate is ionic compound. When you put it into water, these attached water molecules will go to water. Copper sulfate will dissolve into copper 2 plus, dissociate into copper ion and sulfate ions. And in water, so this is a copper ion that can be surrounded with water molecules. So we call it as a coordination compound. And sometimes you can have 4 water molecules, which is a tetra complex, and sometimes you can have 6 molecules, that's an octa complex. So when you have 4 water molecules, so this is going to combine to give you a complex with 4 water molecules, which is copper, water, 4 water molecules surrounded. Copper will be surrounded by 4 water molecules, and this is going to be a cation. So water is a neutral ligand. So we call these compounds or these molecules as ligands. So water is a neutral molecule, doesn't have any charge in it, and it is asking what is the name of this complex ion. Now this is not a complete compound because we are only giving you the positive one, which is a cation of the coordination compound. So you need to find out the name of this complex ion. So when you are naming the ion, first you have to say how many ligands are on the cation. So water is named as a hydrate. Let's see. Okay, so this is how you're going to name it. First you have to say how many water molecules. So remember, mono, di, tri, tetra. So there are 4 water molecules. And then the water is named as aqua. When you are naming ligands, water will be named as aqua. So there are 4 water, so tetra aqua. And then the charge of the copper ion also we need to mention. So the charge, since the water molecule is neutral, so when you add up the charge of the copper plus there are 4 water molecules, the total charge should be equal to the charge of the cation, which is plus 2. So since water is a neutral ligand, it does not have any charge, that's going to be 0. So copper charge plus 0 equals plus 2, give you that the charge of the copper ion is plus 2. So you have to say tetra aqua copper 2 cation. Okay, that is the name of that. The next one, question 4. This cation present after you dissolve the initial solid will be reacted with concentrated ammonia. So the first step of this experiment is that you're going to be dissolving this solid copper sulfate pentahydrate in water, and then you're going to add a stinky ammonia in the hood. Excuse me, concentrated ammonia, and then the product will become copper amine complex. Now you have a different ligand associated with it. Now this tetra aqua copper, what happens is when you add ammonia, you have this equation in your textbook also. I will go ahead and write it down here so you know what's happening. So your compound copper, so to this one you also have dissociated sulfate ions. Remember, we started with copper sulfate, so sulfate ions are also in your solution, and then when you add, so you have ammonia. Now these water molecules are going to replace by ammonia, then it is going to form this complex. Again, you can find out this equation in your textbook, copper amine, and then I run out of space. Right after the square bracket is sulfate, because the first part within the square bracket is your cation and sulfate is going to be your anion. And this also has some water molecules associated with it. plus 3 water. And with 4 ammonia. I'm going to go ahead and write that copper amine complex separate here, so you know it is just one thing. So copper, ammonia, 4 ammonia ligands. That's your cation, and then this is the anion, and to this a water molecule is associated. So what I wrote here, excuse me, I'm sorry. So I wrote it down there. Excuse me. Okay. Now we isolated this part, and this question is asking what is the name of this part. Okay, question number 4, I'm reading it again. The copper aqua complex cation that is present after you dissolve the initial solid will be reacted with concentrated ammonia to produce a soluble complex ion. What is the correct name? You will probably find it helpful to read section 23. Okay, so now we need to name this part. So this is the whole complex, and this is going to be your cation, and this is going to be your anion sulfate, and this is going to be the water molecule associated with it. So when you separate the cation, that is going to be copper, ammonia, 4 ammonia atoms, and since sulfate is -2, your negative ion, and then the positive side is +2, which is also given here. Now let's see how to name this complex. Now ammonia ligands are named as amine when you are naming the coordination compound amine. Again, there are 4 amine ligands, so 4 would be tetra. So that would be, first you have to say the number of ligands, tetraamine, and then the charge of the copper. We need to find out the charge of the copper. Now ammonia, NH3, similar to water, is neutral ligand. It doesn't have a charge on it. So as a result, remember the copper ion charge plus the 4 ammonia charges should equal to +2. That's how you get this +2, the charge of the copper plus the charge of the ammonia. And then the ammonia is 0, doesn't have any charge on it, so the copper is +2. So we have to indicate in our name what is the charge of the cation. So that is going to be then tetraamine copper 2 cation. Tetraamine copper 2 cation. Okay, so that is going to be the name of that compound. Okay, the next one, the final product of this reaction, which is going to be tetraamine copper sulfate monohydrate, is soluble in water. What will you add to the solution after you add the concentrated ammonia to cause this product to precipitate out of the solution? Now I know the answer, but I want you to read the procedure and find out what you need to add in order to make the solution to become a precipitate. Okay, so read the procedure and you can answer that. Question number 8. You will isolate copper amine sulfate before you leave the lab on day 1, and then you come in day 2 to get the mass. Why you need to do that? Again, you can read the choices. This is a long experiment and you want time to weigh the product before class ends. That's not correct. We wait to weigh the product without time for any water and ethanol to evaporate completely. If the product is wet, the measured yield will be too high. It will take several days for the solid to precipitate. No, that's not right either. It is not necessary to wait several to determine the mass of the product. Okay, several days, I believe. There's one word is missing in the last one. It is not necessary to wait several days to determine the yield. The mass of the product isolated can be determined on day 1. So that is a correct answer. So you figure out which one is the correct one. Okay. Alright. So the next one. Suppose that you weigh out 6.95 grams of copper sulfate pentahydrate to begin with. So you were supposed to take 7 grams. So sometimes we might not get exactly 7 grams. So 6.95 is perfect. at the beginning of the experiment. How many moles of copper 2 plus ions are present in this sample? Express your answer to three significant figures and do not include units. So you started with 6.95 grams copper sulfate pentahydrate. Now you need to find out what is the number of moles. Excuse me. Excuse me. What's the number of moles of copper sulfate pentahydrate? Remember, in question number 2, you found out the molar mass of copper sulfate pentahydrate. So you started with grams. So you put the molar mass, which is the answer from your question number 2. I think that's when we found out. Is it question number 2? Calculate the molar mass of copper sulfate. Yes. And you write it down here. Answer for question number 2 in grams. And that is, if you take 1 mole of copper sulfate pentahydrate, that's going to be the mass. So that will give you the number of moles of copper sulfate pentahydrate. Okay. And then we know 1 mole, if you take 1 mole copper sulfate pentahydrate, how many moles of copper are there? How many moles of copper? 1 mole, right? So that means 1 mole copper. Okay, so you write down your answer that you get from question number 2. Excuse me. I'm going to write down a random number, but I want you to do your calculations and see what you're going to get. This is just a number that come to my mind. I just assume this is going to be the molar mass of copper sulfate pentahydrate, but I want you to do your calculations and get the correct answer. Let me write down like 249.72. I don't trust this number, so you guys figure out what is the correct number. Okay, so 6.95 gram copper sulfate pentahydrate. You take the molar mass of copper sulfate pentahydrate. That is the amount you find in 1 mole of copper sulfate pentahydrate. And then the molar ratio, if you take 1 mole of copper sulfate pentahydrate, it has 1 mole of copper. So basically what you need to do is you take 6.95 gram and you divide it by molar mass of the compound. That will give you the number of moles of copper ions present in this sample. Okay, which is also the number of moles of copper sulfate pentahydrate. 1 mole copper sulfate, 5 water molecules. You will see what I'm trying to write here. Okay, that's how you calculate the number of moles. Next one, what is the molar mass of copper amine sulfate, tetramine copper sulfate? Again, you know how to calculate the molar mass. From the periodic table, you add up the atomic masses. Okay, all right. And then if you use 6.95 grams of copper sulfate pentahydrate starting material, what mass in grams of the copper amine sulfate hydrate product would you expect to isolate at the end of the reaction? And this is also the theoretical yield of the product. So basically, remember what we are trying to do is you first started with copper sulfate pentahydrate, copper sulfate pentahydrate. You take 6.95 grams of this and then you dissolve in water, you add ammonia and you have the balance equation, and will give you this compound at the very end. This is what you're going to have: copper amine tetramine sulfate water. Okay, and this is a 1-to-1 ratio, 1 mole of copper, 1 mole of copper. So 1-to-1 ratio. Remember, we found excuse me, number of moles of copper sulfate pentahydrate, and we also found in question number I believe we did it in question number 7. Yes, question number 7. Let me write down what I got. 6.95 divided by 249. I'm going to go ahead and write down the answer for that. Again, you may want to check these calculations yourself. 0.278 moles. Okay, so 0.0278 moles copper, as well as that is the same number of moles of copper sulfate pentahydrate. Okay, because we started with 6.95 grams, so that's the number of moles, 0.0278 moles. Remember, according to the balanced equation, 1 mole of this will give you 1 mole of that. So if you started with 0.0278 moles of copper sulfate pentahydrate, you're going to be also making 0.0278 moles of your final product. Okay, what you need here is what is the mass in grams of the final product, which is this product. So if you know the number of moles, can you find out the mass? How do you do that? Using the molar mass of copper amine sulfate, which you calculated in question number 8. So you take this number of moles, 0.0278 moles of this, and you use the molar mass you calculated in question number 8. 1 mole of copper amine sulfate is the molar mass, which is the answer you get in question 8, which is the molar mass of copper amine sulfate water molecule. Okay, so you multiply. You have done these kind of questions many more times before, even in Chem 1. So number of moles times the molar mass will give you the mass in grams. Which is also going to be the theoretical yield, meaning if your reaction goes to completion without any trouble, without any side reactions, without you spilling anything, that's the maximum amount that you're going to be making, which is going to be the theoretical yield. And then the question 10, suppose that you start with 6.95 gram of the copper sulfate pentahydrate, you only isolate 5.06 gram. That's going to be your actual yield. Actually, you isolated this much. What is the percent yield? So how do you calculate the percent yield? Percent yield, you have done this several times before. Actual yield times the theoretical yield times 100. So your actual yield is 5.06. 5.06 grams. You divided it by the theoretical yield, which is your question 9 in grams times 100. This will give you the percent yield. 5.06 you divide by the answer you get in question 9 times 100. Okay, that's all the questions. Hope you understood how to do the calculations and the naming, and that's it for now. Bye bye.